I recently was working on a project where I needed to search for a file basically from the root directory down. And you can do this with the search bar in Internet Explorer. But the problem with that is I needed to cut and paste information out of the search results and put it into other note file and development documentation. And I wasn't able to do that. For some reason you can't cut and paste the results. So I basically went back to the program that we wrote in Video 87, which was a search for file name program. And I said in that video that this would only search for a specific directory. It wouldn't go outside the directory you specified with the browse. And I said you could increase the functionality and go to subdirectories by using the recursive algorithms that I discussed in Video 84. So that's basically what I did. I combined Video 87 and Video 84 and created a recursive find file program. And because the main thing I wanted to do was cut and paste, I changed the nature of a couple fields. This used to be a read-only text field, and now it's read-write text field. And this used to be a list box, and it turns out you can't cut and paste from list boxes either. So I changed this into a multi-line text box. If we look at the code behind the browse button that allows you to specify a directory, it basically pops up a folder browser dialog and then checks to see if you actually selected a folder and sets that as the root folder. It's no longer the only folder, but it's the root folder that you recursively go through any subdirectories and any subdirectories under the subdirectories and so on. So this code is pretty much identical to the code in Video 87. But if you look in the code behind the search button, this is completely different. It checks to see whether there's a file name to be searched for in the text box. And if there is, it sets a global variable called str directory to that file name. Or actually that sets the directory from the directory text box to that. And then we call a function called a init search. And a init search clears out the results box and sets a series of exception counts to 0. And I'll discuss these in a minute. And then it does a file search recursive with the directory that we specified. And then when we're doing the recursive search, that's when we actually look at the information in the file name text box. But the problems I ran into with the recursive search is if you're searching from a subdirectory down the tree, you don't have any problems. But if you actually search from the root, it turns out you get all kinds of exceptions of directories that you're disallowed to look at and disallowed to get directory information from. So within the file search recursive, I get directory info from the current directory or the specified root directory, and then I call a function called list hits, which is pre-order recursion because I'm doing something before I recurse. And then I get directory information from this directory that we just got. And if there are directories, this array of directories will be greater than 0. So we'll need to go through each of these directories and recurse, basically recalling ourselves with the current directory name, the fully specified directory name. So this is the place where we actually do recursion. And one of the first problems I noticed is there's directories that start with $. And these are some kind of system directories that you have no rights to. So I basically do a substring 0, 1, which says starting at index 0 in the string for a length of 1. If that is equal to $, then don't recurse. You know, only if it's not equal to $, recurse. And I was hoping this would be enough, but it's not. There's also all kinds of other directories that are defined as some kind of system directories or shortcuts or something that you don't have access to. So I have the try block that does the recursion, and then I have a catch of IO exception and another catch of system.unauthorized access exception. And this second one is the biggie. You get a ton of these if you start from the root directory. So we're going to get a ton of these exceptions. Originally I was popping up a message box that showed the message of this exception and a message box that said the message of this exception. So I had IX after the IO exception and UX after the unauthorized access exception. And then if I specify UX.message, it'll print out the message. But it turns out if you do that, you're going to be hitting OK a couple of hundred times. In fact, like 400 times, I think. So I just commented that out, and I started incrementing variables that said how many of these exceptions I got. And it turned out to be a lot. So if you didn't have this try-catch block, this code basically wouldn't work at all. And then within the hits, list hits, which actually does the functionality, we get directory info from the current past directory, which we're going down directory chains, going to different directories. And then I get all the file names from that directory. And basically I get the search string from the text box that we typed in the directory name. And I loop through all the file names that we have in this current directory. And if the index of the search string is equal to -1, it means it doesn't match. So basically we do nothing if it's equal to -1. And I set both the file name to upper with this function and the search string to upper. So this makes it case insensitive. And if we get something other than -1, it means we got a match. So we basically append to the text box that we found the current file name, and I give the full name so we have the directory information of where we find the name, and I put in a new line so we'll get everything on a nice line within the multi-line text box. And very importantly, I do a text box update. Otherwise you're going to be sitting there looking at a blank screen for the amount of time it takes to run, which amazingly isn't that long with the text box. It's much longer with a list box than it is with the text box. But with the update, you immediately see any hits you get. And then within this list hits, I also have an IO exception and an unauthorized access exception. And I update different counters to show I got exceptions for the list hits as opposed to getting exceptions for the file search recursive. And the only other code really is the initialization and end of day code. And that basically says within the main button press handler, do a initialization, then do the file recursive, then do the end of day processing. And in the initialization we clear the text box, the results text box, and we initialize all these variables, and when in the end of day we create a huge string that says we searched all the files from our root directory down. And then it says the list hits IO exception and gives the number of those, changes the number to string and does a new line. And the list hits unauthorized access exceptions, changes that to string and does a new line. So basically in the message box at the end we print out how many of these exceptions we got running the code. So if we compile and run this, and I paste in the file name I'm actually looking for, and I just leave the default directory of the root directory and hit search, You see, initially it takes quite a while for the searches to start to appear. And the first group we got is in a main directory called Lana, which is a backup of an old computer that had this in the basically in the Netflix 4 or NetFX 4 directory. And then we see the same thing for the actual program files in the bin directory, and then the same thing in the 64-bit directory in the program files. And when this ends, the message box should pop up. And as you can see, the message box shows that there were basically a ton of I/O exceptions and unauthorized access exceptions. The I/O exceptions, there was just one in each of the calling routines, and the unauthorized access exceptions, there was 187 in both routines. Coincidentally, the police code for murder. But basically, what this means is if we hadn't written those try-catch blocks and specifically looked for I/O exception and unauthorized access exception, if you use a general exception, it won't work. I tried it that way. Basically, if we don't put that code in there, this code wouldn't work at all. Well, if we close this message box and say go to this line and this directory, and select it and right click and copy that, and then paste this into what is now a writable text box for just this purpose, and I do a browse for this. Keep in mind I paused a number of times running this, and I'm going to probably after the fact edit out a lot of time going by, so this program took a long time to run from the root directory, although if you don't know where it is, you have to take the time. So if I press browse from this subdirectory, what am I doing? I already put it in there. If I press search with that subdirectory in there, you see the information pops up immediately, and there were no I/O exceptions. So if you know where it is at a local location, you can definitely speed up the process. And cutting and pasting is what this program is really about, why I changed the nature of these two fields. Well, I hope you enjoyed this video and learned a lot. There's actually a couple buttons I haven't talked about I'll talk about in the next video, and there'll probably be at least one more. But I think we've definitely had enough information for one video. I'd appreciate it if you'd subscribe.